Okay, so hello, and today we are going to look at solving just a pretty basic heat formula, heat problem using the heat formula, and I suppose this would be at about a grade 10 or maybe grade science 10 or possibly early grade physics 11 problem. Okay, so here we have our given our given problem. How much heat energy is required to change 357 grams of silver, and here is your specific heat capacity for silver, 0.230 joules grams degrees Celsius, at 24.6 degrees Celsius, and it increases up to 28.9 degrees Celsius. Okay, first thing I do with my students is have them write down the formula. So here we have our formula, and once we have this, these are steps that I find helps students to minimize or eliminate careless mistakes. So I have them write this down just like this, MC delta T, just in the column, like so. And I'll tell them that this is worth points for your problem as you work it through. And they will do it this way. And it certainly decreases careless mistakes, and I'll show you why. So here we have how much heat energy is required to change 357 grams. Okay, so I'd say grams. What is that a measure of? And they should know that mass is measured in grams, so that tells them that that value goes there in their column. Next, this one is usually the easiest one to pick out because it's the one with the craziest unit, joules, grams, degrees Celsius, and that is your constant. And in this case, it is silver and 0.230 joules grams degrees Celsius, 24.6 to 28.9. So we know that delta T is temperature final minus temperature initial. The final temperature is 28.9. Subtract 24.6. And that gives us 4.3 degrees Celsius. Now, I'd say to my students, which is the only variable that does not have a value? And of course, they're going to tell me that it's Q, okay? And then I'm going to say to them, well, that is our unknown. And I usually put an X there just so that the students know that's the guy that we're looking for. And if you go back to the problem, how much heat energy? Heat energy is a measure of Q, which is measured in joules. So that's the first step. Then we go back and we rewrite the formula and we plug in our values. So 357 grams, silver is 0.230 joules grams degrees Celsius, and our delta T is 4.3 degrees Celsius. Okay, when you multiply, this is standard multiplication here, 357 times decimal 230 times 4 decimal 3, it works out to be 353 decimal 073. Now, I'm going to write this down joules, and then I'll go back and I'll show you why the unit is joules. Here, this is why, again, it's very important for your students to identify and write down all of your units, and then you can see, look, these grams cancel each other out, okay, as you multiply this problem through, and another unit that will cancel, degrees Celsius. So you can see the unit you are left with is joules, and that is what Q is measured in, joules. So we have our answer. We're not done yet. Maybe at the beginning of the semester you might accept this as your answer, but as you typically I do significant figures and significant digits with my students prior to doing something like this. So I would expect that my students answer this question using the proper number of significant digits, and I have my students refer back to the initial problem and we count off. So there's 3 significant digits here, This one here is actually kind of easy because look, there's 3 here, and there's 3 there as well. So that tells us that there would be 3 in our answer. And we look, there's 1, 2, 3, so we know we're going to look to this unit, this place, sorry, and we look, that's a 0, so that would indicate to us that our final answer, using the proper number of significant figures, is 353 joules. So, to answer the question, you would indicate or say it takes 353 joules of heat energy to increase the temperature, to increase a piece of silver 357 grams from 24.6 degrees Celsius up to 28.9 degrees Celsius. Okay, thank you, and have a great day.